Hello, this is Dr. Flight, and this is going to be a video that will walk through some elements of discriminant analysis, validation, and then some other side topics relating to validation and finishing up discriminant analysis. So a key thing about validation is that we want to make sure that whatever our functional discriminant functions are, that they can be repeated and that they can be repeated with a fair amount of accuracy. So that's one of the key things that we want to think about, and that when we create the initial functional discriminant functions, we are checking the accuracy of those functions to data that was used to create the functions. So the argument here is that the functions are somewhat circular, and that they're validating, we're using data like with the hit ratio. Is basically the hit ratio is like a measure of our function's ability to predict, class membership, but the class membership that it's predicting was used to create the actual discriminant function. So it's a little circular. And so the key here is we want to be able to double check, triple check, and be able to use these discriminant functions reliably over periods of time. So that's this whole idea of validation and making sure that we have predictive accuracy and things like that that we're concerned about. One technique, and we'll talk about a few other techniques here too. One technique is called is the idea of having a holdout sample. So if you have a data set and you randomly split the data set up, then you'll be able to run your initial analysis on some of the data, but then you'll have some of the data that's not initially used to create the determinant functions. And so then what you can do is you can create the probability scores, the functional scores for the holdout data, and then use that and compare that to the actual results. And so you can get a feel for you can actually again get a second hit data hit kind of an accuracy score then based on the holdout data. And that would be very, very good to do. In fact, it's ideal if you can. So holdout samples then are one way to be able to do that. There are other validation methods, bootstrapping and jackknifing. Jackknifing is a deal where bootstrapping and jackknifing basically are techniques where you repeat the process over and over and over again, and sometimes you even create new data that would simulate the data that you had. So in other words, if I have 100 respondents, sometimes what I can do is I can create like a whole new data set that simulates the characteristics of the 100 respondents and keep running the data over and over and over again. So artificial samples are created in that case. Yeah. When you bootstrap. When you jackknife, you again create samples, or you use samples, but you eliminate data points and create separate models to be able to see how reliable the prediction is after the eliminated point or data is made. So these are validation methods. They are possible in SPSS. Holdout samples obviously are impacted by your sample size. If you have a small sample size, then holding out some of your data isn't always possible. right? So you have to have sufficient sample size to be able to hold out data, or you have to collect data a second time or whatnot. So holdout data it may be the simplest thing to do, but it may not be feasible. Bootstrapping and jackknifing, bootstrapping especially, is pretty common. So it wouldn't be something to be too concerned about. But validating your data is a big step that you want to do. You don't want to be surprised by having to do it and seeing bad results or whatnot. So running a double check and validation there is certainly something to do. And again, you're looking at like the hit ratio, or you're looking at the overall accuracy of the predictive model, and making sure that it holds up over lots of different data collections, basically what you want to do. Other things that we talk about here as we wrap up this is definitely measuring and picturing your data. So we've looked at this before, but we know that we can plot our data points in 2 or 3 dimensional spaces. So that's something that we want to do once we have our scores and the centroids. So we have individual respondent scores on the functions. So each function provides a score on each respondent, and then we can map and chart those, and we can see what those look like specifically. We also have a centroid score for each individual, for each cluster or each grouping that we have. So illustrated in a number of different ways may be the groupings. Here we have the different colors here and shapes that are illustrated. SPSS is very robust, so you can make all different kinds of changes here. We also have superimposed on this where the cutting points are for these different groups. So these are hard, fast cutting points, which help us form our groupings, in terms of where they are. Note there's some overlap. So there's, like, for instance, a pink outlier, not an outlier, but a group here, and it's not kind of in its little area, but that's okay. That's not, the point here is to try to predict these perfectly, but of course there's not going to be perfect prediction with these models. It's just kind of a function of what it is. So these territorial maps and grouping maps will be highly valuable to illustrate markets and buying habits and different groupings and things like that. Other elements that we'll mention just briefly, there is something called the press Q statistic. We don't use it much, but I want you to know that there's a term called the press Q statistic for classifying accuracy. We also have the partial F test. And again, not something that we use very often, so we're not going to talk about the partial F much. We talked about F tests earlier when we were looking at the overall model. And we had one chart that we looked at that looked at the interrelatedness of the variables, and that was in the HBAT example. So that chart, that table that did that is what you would actually look for this particular variable. It'd be like the pairwise group comparison table, and so it'd be the F for pairwise distances option if you're doing a stepwise type of a regression. So we looked at that before, but again, it kind of is a little redundant if you have solid F statistics and solid F statistic for the overall model. So is the potency index. Okay, so you can look at the eigenvalues. There's actually a table that's returned in the output file that will be the eigenvalue and the eigenvalue loadings. And again, eigenvalues help you understand how much variance is being contributed, how much variance is being explained as a composite and a composite measure. Again, it's not something that is used exclusively or in a lot of with a lot of emphasis. A final note here that may be helpful to make is that there are a lot of other multivariate analyses, of course, and some of these analyses overlap and have a lot of similarities with each other. So discriminant analysis is not a regression. However, it has some regression features that would be similar, or things that you would think of. So like betas in regression are similar to the weights in discriminant analysis, but they're not the same. They're slightly different. So in discriminant analysis, we're creating functions which are similar to factors in factor analysis, but they're not exactly the same as a factor in a factor analysis. They're not used the same. They're not really used the same way. Discriminant analysis uses groupings that are predetermined for the dependent variable. So dependent variable has to be non-metric, and they're groupings that we've pre-designed and we think of in advance. That may be a little bit different than logistical regression, for instance. So think of like the different tools that you have and the slight nuances that each will provide you, and think about the approach that you're taking philosophically in terms of how you're viewing your data, and that will help determine what method you want to use. So so we know there are differences between discriminant regression analysis. ANOVA and MANOVA may have metric dependent variables, but it might also include non-metric. It does include non-metric independent variables. So instead of non-metric dependent variables, we have non-metric independent variables. Regression, as we know, has metric dependent and independent approaches. Okay, so that's kind of, there are differences here. One element that we're going to lead into moving forward will be logistical regression. So logit models and logistical regression or logistical analysis may be an alternative to discriminant analysis. And one of the things about discriminant analysis too is you're really kind of creating a probability, which is very different than a beta as well. So those weights combine to create kind of like a probability, not really, but it's kind of like a probability of group membership, the likelihood that an object would fall into one group versus another. In other words, is kind of the interpretation of discriminant analysis, and it follows that logistical analysis and probit models and logit models are kind of in the same vein there as well, in that they're probabilistically kind of interpreted. Okay, so logit models are going to be what we move into next. It's a type of, like, logit models are a type of regression as opposed to discriminant analysis, which is factor-based. But we only use two instead of two or more levels as dependent variables. Right, and because it's more regression focused, it's a little bit easier to work with in terms of assumptions, and we can have non-metric independent variables. So we can use dummy variables, which would be which we have to do if we're going to do a regression and we're going to have non-metric independent variables. Then they have to be in the form of dummy variables for that to work out. So one of the things to leave you with is, if you have only two levels, then you may want to do a logistic regression. If you have more than 2 levels, then you need to do a discriminant analysis. Okay, so that may be a decision point that you make as you, as a researcher, as you're thinking about your tools and the methods available to you. Okay, so anyways, this wraps up what we're going to talk about here. This is a short and sweet little discussion on just the validation idea, and then some miscellaneous pieces that I didn't really have a chance to talk to in other areas, and then also a foray into our logistic regression material that will happen in other sessions. Okay, thanks. Please ask if you have questions. Look forward to talking to you soon. Thanks.